Hi everyone. In this video, I will show you how to do your computer project, which is a part of mechanical system design course. First thing you need to do is to download these files, which probably come within this zip file for parts from Icon. And also there is this manual for SimCenter. It's either in Word document or it's PDF, and the project description. So let's check the project description first. So here we have this 4-bar linkage that we want to model in a software that we'll see. And this is a description about this linkage, and later after you finish simulating the computer, you have to do the same with hand and compare results. And these are the requirements for the project. Between the requirements, there are three that you have to take a picture of some part of your job, and I'll point out when is the time so you wouldn't miss this. So uh, and we're gonna use VMware for this to connect to the computer lab. So to have these files in the other computer, you can pick them and drag and drop. Then you better create a folder here somewhere, either in this address or in this address. I use this one. And in documents, it's funny, I already had some folders here. I don't know why it doesn't show up. No, here it is. No, they're different. All right. So I'm gonna call this mechanical systems design and put these files here. So This is the software that we want to use. It's called Siemens. There's a folder here, Siemens NX, and SimCenter 3D is the one that we're going to use. Also, I will open the SimCenter manual to see it side by side. So I rather do it like this, keep this window in this size, so whenever I want, I can click on this and go back here. So the first thing is we need to open a new file. New, it's going to be an assembly. And for folder, I will go to the place that I created this. Okay. H documents, MSD. Okay. So we have these 4 files that we have to import them to the software one by one. And we're going to start from the ground one. So this is the add component, a window of the software, which you can have access to it from here, assemblies, add component, if it didn't show up the first time. I will import the ground as my first element here. Ground, and then you have to change this assembly location to WCS. And there's nothing to do. So, okay, and yes. I could have pressed apply, but I went with OK, so I'm going to need to click on add component one more time. The next one would be crankshaft. Here it is. And you have to relocate this, so I will click on constrain and concentric. Pick either of these 2 edges so the software can find the center of that curve, and also center this, and there you go. And since they are on top of each other and overlapping, we have to move it. So here there's before I do anything, I will click on apply, so we make sure that it's here. Now I will move this component, select it, this one, and using this manipulator, move this 90 degrees to the other side. Make sure you're doing this to in the positive side. The other time I made it to the negative, and all my results were mirror of what I was supposed to get. So yeah, move it to the other side 90 degrees and apply. So we're done here. No, not here actually. Cancel. So the next one is we need to bring the coupler. And with the coupler, we have to attach these two ball and socket. And this is going to be a fit constraint. So we're going to use this fit. I'm clicking on this. Using middle button, you can rotate your view. Click here and click here, and it goes there. So apply. And the last one is the rocker. So again, open, rocker, okay. So this time we have two constraints. This should go there and this will come here. So this is a fit. So now that I'm here, and if it didn't work when you wanted to select, just click on another one and then go back to it. Fit from here to here, and concentric from here to here. Okay, and apply. Now you should have something like this, which if your X, Y, Z direction are in these directions, your mechanism should look like this, your linkage. So here we need to take a picture of this. So this is the first picture that you have to put in your report. To do that, I will use a snipping tool of Windows, New, from here to here, and then save as, same place that I made my folder. I did it in this drive and one. Oh, usually when you sign into a new computer, your num lock is off, so you have to make it on. Save. Okay, this is our first picture. So after this, we have to set this to its initial condition that we want. We want these two to have 90-degree difference. So I will go to assembly constraint and an angle type constraint, and it says like to object, so I will rotate just a little bit. This one and this one should have 90-degree angle between them. So here we have this, and again you need another picture from this view. Two. Save. So the next step is to introduce emotion to what we have created so far. So right now what we have here is just 4 graphical elements that we imported to the software. Now we have to define them as some mathematical objects that the computer can do the simulation based on them. So I came to the, I think it was, yeah, it was application. I clicked on motion, and now I'm going to click on new simulation. The same place with a different name. Okay. In the old version, there was another option here, kinematics or dynamics. Here we don't have. Just make sure you uncheck this wizard. We don't need that. Okay, and then so we have to define all these things that we imported as links, except for this one, which is the ground link. These three should be introduced. So here I click on motion body, click on this, and its name would be B001. Okay. Again, so now if you see here, we have three motion bodies, which in the old software, uh, the name would be L00. Let me see if we can see it here. Oh, it's probably, no, here it is. This was L00. Here, for some reason, it's B00. It doesn't matter. It was link. Here it's called motion body. That's fine. Then after this, we have to create joints or define joints. The first one is revolute. The second one is spherical. The third one should have been spherical, but because we don't have any motion in the z direction, we're gonna constrain that direction and use a cylindrical for the third one. And fourth one is again revolute. So let me go back here. Okay, so joint. For the first one, I will, first of all, this is revolute, and then I will click on this arc here. Okay. And then I have to also give the direction. So click on this invert vector, and let's pick this z-axis in the positive direction. Okay, this is our first joint. The second joint would be here. Joint. This is spherical. And here. And this time you need to define another object as your base. So I will click on this. The previous time, since your base was ground, you didn't need to define that, but now we have to. And now for the vector, I have to pick the z direction again, which is this one, the axis. So, okay. So here we need to introduce another joint, this one. The previous link would be the base, and the direction is the axis. And fourth one, sorry, this last one should have been cylindrical, I forgot. So come here, edit, and turn it to cylindrical. And I think everything would be the same. Let's redefine this direction, and space is the same, so cylindrical. Okay. And the last one is here, joint. And again, you don't need to define any base for this one since it's attached to the ground. And the axis, and okay. So we have these four joints. I'm gonna bring it here and take my third picture. and save this. Okay. Now we have to input the motion that we want. So the motion is applied on the first bar, or B001. So here I will click on this edit. In the edit, there is what? Driver. Is it this one or the joint? No, no, it's not this one. It's the joint. Sorry. I have to edit the joint here. And now that I changed this, I realized that this should have been Revolut. Sorry. I forgot to change this to Revolut. And I assume everything is correct. So edit the driver, it would be polynomial, and the velocity is 120 degrees per second. Okay. So the next thing is, in your project, we need to keep track of the motion of center of this bar. So to be able to do that, we have to define a marker. Find a marker here in the middle of this, and its movement would be relative to this point. In the older version of the software, we had to define this relativity, but turns out that here you don't need to do anything. You just need to click on this, pick the center, and it would automatically be relative to this point. So, okay. And then after creating your marker, you have to create two sensors, one for keeping track of the displacement. So this is displacement in y direction, and the absolute value. Is it absolute or relative? Oh, it's absolute. So, which since that point was 0, 0, 0, both are the same. Doesn't matter. And select object as your object here. You have to select this marker. Okay. And you need another sensor. This time, velocity in y direction, absolute, and same marker. Okay. So now you have two sensors here. And now I have to define the parameters for my solution. I click on the solution. 5 seconds, I think we need to do this. 5 seconds and 200 steps. And also this window is different than this. Here, instead of a step, you have a step size. Change it to steps, number of steps, and make it 200. Okay, and everything is fine. We can solve this. So 100% progress. We're done here. So the first thing to check whether this works correctly or not is to go to results and play an animation, and this works correctly. So finish. Now you have to get your results out of this. You can return to model as it says. I clicked on finish. They are both the same, I think. So here in the sensors, click the first sensor, then come here in the XY view, double click on this, and you can create it in a new window. So this is the motion of this point. It starts from this Y, because we're looking in the Y direction, y is 370, and it goes down up to this point and then goes up and comes down, which is what you should get, similar to what you have in your report, in your, I mean, manual. So, and you have to check the value of your displacement in 3 times, 0, 1, and 2.5. To do that, right click here in the probing mode, single X. Let me make it bigger. And then let's get rid of this, put it here. And then you have to pick this and let's say bring it to 1. And write down this number, and again at 2.5, write down this number and also at 0. Later you're gonna compare these numbers to numbers that you get from hand calculation. So also take a picture of this and put it in your results. And the next thing is you go to the second sensor, double click here in the new window. And as you see, our results are the same. And again, you have to go through these 3 moments and take your velocity. And there we go. Let me take a picture of this. Let's make this bigger and take a picture. And there you go. This is an easy simulation, and I think I did it in like 10 or 15 minutes. You might be able to do it in less than half an hour. So good luck with this project, and if you have any questions, I will be available through class times via Zoom, and you can join and ask your questions. Thank you and good luck.